All right, when we talk about temperature, really what temperature is a measure of is the kinetic energy of the substance. So when we say something is hot or something is cold, it's always sort of relative to each other. If you're comparing hot versus cold, all that means is that the hot object has more kinetic energy than, or the substance in that hot object, the molecules, atoms, ions, have more kinetic energy than the kinetic energy of the cold object. So that when you put your hand on something that's hot, it transfers kinetic energy to you because those particles are bumping into you with higher kinetic energy and transferring energy to you. The temperature scales, or units, the units that we use for temperature depend on what scale you're using. There's three main scales used. There is the Celsius scale, which has units of degrees Celsius, or degrees centigrade, a little bit older term. There's the Kelvin scale. If you've never taken a science course before, you've probably never heard of it, but it's a good one. And we will use it in this course. Units are Kelvin, no degree sign. And then the last one is, if you're from the US, probably a little bit more familiar with the Fahrenheit scale. And that has units of degrees Fahrenheit. The different units or different scales are set up on different set up various mechanisms. Celsius scale is based on two very important physical properties of water. In that, set the 0 degrees Celsius mark for the freezing point of water. And then the temperature at which water boils was set to 100 degrees Celsius. The Kelvin scale was based on absolute 0. Which is the temperature at which, well, if you think about kinetic energy, temperature is a measure of kinetic energy. If the sample has 0 kinetic energy, that is what's known as absolute 0. No molecular motion, 0 kinetic energy. You can't have negative energy or negative kinetic energy, and so that is pretty much what Kelvin is based off of. Absolute 0 or 0 Kelvin, temperature at which there's no kinetic energy in the substance. It turns out that water freezes at 273 Kelvin and boils at 373 Kelvin. So you can see that in both scales there's 100 degrees between those two factors, and that for every 1 degree Celsius of an increase there is, you also go up 1 Kelvin. So that's nice. Interconverting between Celsius and Kelvin is actually pretty simple. You just need to add or subtract the difference between the two scales, and that is, of course, 273. So if you want to convert to Kelvin from degrees Celsius, you would add 273.15 to be a little bit more exact. And then, of course, if you're going from degrees Celsius to Kelvin, you would subtract that value. By the way, that puts absolute 0 on the Celsius scale at negative 273.15. The Fahrenheit scale was based on some systems that the Fahrenheit was after, but essentially at the end of the day that it turns out that water freezes at 32 degrees Fahrenheit and boils at 212 degrees Fahrenheit. That's going to give us some issues for interconverting between Celsius and Fahrenheit, because you can see that the difference between those two points of water, boiling and freezing, is 100 on Celsius, and it's actually 180 on Fahrenheit. So that means for every 1 degree Celsius, for one increase, 1 degree Celsius increase, you're going to have an increase of 1.8 degrees Fahrenheit. And so when converting in between Celsius and Fahrenheit, we need to take into account both of those. We need to account for both of those features. And so when going from Fahrenheit to degrees Celsius, we're going to subtract off the difference between the two scales, 32. So Fahrenheit minus 32. And then also divide by that 180 over 100, or 1.8 over 1 factor. So we're divided by 1.8. And then when converting from Celsius to Fahrenheit, which is usually much less common, but we would have to multiply the degrees Celsius by 1.8 and then add 32. Alright, so let's get some practice on using those new equations. Alright, so let's convert normal body temperature, 98.6 degrees Fahrenheit, to Celsius and Kelvin. Alright, so the first one, the easiest to convert to Celsius first and then to Kelvin. Those are the equations we have, and converting from Celsius to Kelvin is rather straightforward. Alright, so if I want to convert from Fahrenheit to Celsius, I'm going to use this equation. I'm going to subtract 32 and then divide by 1.8. So we're just going to insert that 98.6 into our equation. So 98.6 degrees Fahrenheit minus 32 all over 1.8. So into my calculator, I have to follow my orders of operation. So remember to do the addition and subtraction first, and then the division. So 98.6 minus 32 divided by 1.8, and 37 degrees Celsius equals 37. All right. And then next we're going to want to convert to Kelvin. So Kelvin equals our degrees Celsius plus 273. And that would give us 37 degrees Celsius plus 273 equals 273 plus 37 equals 310. 310 Kelvin.